A typical residential solar panel system costs between $15,000 and $30,000 installed. A Stirling engine generator that produces comparable power output can be built for $300 to $2,000. That's not a typo. We're talking about a cost difference of 10 to 1, sometimes even 50 to 1. I'm going to walk you through exactly why these two technologies have such drastically different price points, what you're actually getting for your money with each option, and why one of them has massive marketing behind it, while the other remains virtually unknown to most homeowners. Let's start with what both systems are trying to accomplish. You want to generate electricity at home to reduce or eliminate your dependence on the utility company. Both solar panels and Stirling engines can do that. But they do it in completely different ways, and that difference explains everything about their cost structures. Solar panels convert sunlight directly into electricity using photovoltaic cells. It's a solid-state technology with no moving parts. The panels sit on your roof, absorb photons from the sun, and generate DC power that gets converted to AC power through an inverter. A Stirling engine, on the other hand, is a mechanical heat engine. It uses temperature difference to drive a piston, which turns a crankshaft, which spins a generator to produce electricity. It has moving parts, but they're simple and durable. Now here's where the cost difference starts to make sense. Solar panels are manufactured in massive factories using highly specialized equipment and materials. Silicon wafers have to be grown, cut, doped with specific elements, assembled into cells, encapsulated in weatherproof frames with tempered glass, and shipped around the world. The manufacturing process is complex and capital-intensive. Even though production costs have dropped significantly over the years, you're still paying for advanced materials, science, and precision manufacturing. Then there's the installation. Solar panels need to be mounted on your roof with specialized racking systems. Your roof needs to be evaluated, sometimes reinforced. Electrical work has to be done by licensed professionals. Permits need to be pulled. Inspections need to pass. Your electrical panel often needs to be upgraded. By the time you add up equipment, labor, permits, inspections, and grid connection fees, you're at $15,000 to $30,000 for a system that offsets most of your electricity usage. Now let's look at a Stirling engine generator. The core components are a cylinder, a piston, a heat source, a cold sink, a flywheel, and a small electrical generator. These are mechanical parts that can be fabricated in a basic machine shop or even assembled from readily available components. The materials are steel, aluminum, copper, and basic fasteners. Nothing exotic. Nothing that requires specialized manufacturing facilities. A small Stirling engine that can generate a few hundred watts can be built from scratch for $200 to $500 in materials if you're doing the work yourself. Pre-built units are available in the $1,000 to $3,000 range for systems that can produce enough power to run significant portions of a household. There's no roof work, no electrical panel upgrades, no permits in most jurisdictions because you're not connecting to the grid in the same way solar systems do. You can set it up in your backyard, on a patio, or even in a garage workshop. The installation is simpler. The components are cheaper. The whole system costs a fraction of what solar panels cost. So why isn't everyone using Stirling engines instead of solar panels? Two reasons: marketing and scalability. The solar industry has spent billions of dollars over the past 20 years building infrastructure, training installers, lobbying for tax credits and incentives, and convincing homeowners that solar is the future of residential energy. When you search for home power generation, you get flooded with solar content. Ads, articles, YouTube videos, all pushing solar as the default option. The industry is mature, well-funded, and has massive momentum behind it. Stirling engines, by contrast, have almost no consumer marketing. They're used in some industrial applications and niche scenarios, but there's no multi-billion-dollar industry promoting them to homeowners. Most people have never even heard of them. The second issue is scalability. A solar installation is turnkey. You write a check, a crew shows up, they install the system, you flip a switch, and you're generating power. It's designed to be completely hands-off after installation. A Stirling engine requires more involvement. You need to provide the heat source. You need to understand how the system works. You might need to do some assembly or maintenance. It's not as plug-and-play as solar. But here's what that actually means in practice. With solar, you're paying an enormous premium for convenience and professional installation. With a Stirling engine, you're trading some of that convenience for massive cost savings. And depending on your situation, that trade might make perfect sense. Let's talk about ongoing costs and performance. Solar panels degrade over time. Most warranties guarantee they'll still produce at least 80% of their original output after 25 years. That means you're losing efficiency every year. The inverter, which is a critical component, typically needs replacement after 10 to 15 years at a cost of $2,000 to $3,000. If you financed your solar installation, you're also paying interest over 20 or 30 years, which can add thousands more to the total cost. A Stirling engine, being mechanical, does require some maintenance. Lubrication, occasional seal replacement, things like that. But the components are simple and durable. With basic care, these engines can run for decades. And here's a key advantage. A Stirling engine isn't limited to solar heat. Yes, you can use a parabolic mirror or Fresnel lens to concentrate sunlight as your heat source, just like solar thermal systems do. But you can also run a Stirling engine on natural gas, propane, wood, or any other fuel that produces heat. That gives you flexibility that solar panels simply don't have. On cloudy days, at night, during winter when sun angles are poor, you can switch to a backup heat source and keep generating power. Solar panels just stop working when the sun isn't shining. Now let's talk about the realistic comparison. If you have $20,000 to spend on home power generation, you could install a solar system that might save you $150 per month on your electric bill, with degrading performance over time and a major inverter replacement down the road. Or you could build or buy multiple Stirling engine generators for $2,000 to $4,000 total, use the remaining $16,000 for fuel or system expansion, and have a more flexible, maintainable, and cost-effective setup. The math heavily favors Stirling engines for anyone willing to take a slightly more hands-on approach. So why don't more people know about this option? Because there's no profit incentive for large companies to promote it. Stirling engines are too simple, too cheap, and too DIY friendly to support a massive installation industry. Solar, on the other hand, supports an entire ecosystem of manufacturers, distributors, installers, financing companies, and service providers. There's money to be made at every step, which means there's money to spend on marketing. But for homeowners looking at the actual costs and benefits, the comparison is pretty clear. You can spend $20,000 on solar and hope it pays for itself in 15 years, or you can spend $2,000 on a Stirling system and start saving immediately. I've put together a detailed cost breakdown in the description comparing both systems across different scenarios, including materials costs, installation requirements, and long-term maintenance. If you want to understand energy alternatives beyond what the solar industry is pushing, subscribe for analysis that compares what these systems actually cost versus what they actually deliver. Solar works for some people, but it's not the only option, and it's definitely not the cheapest.